Hello guys, welcome to our channel. Mansur Khan is here. So today I'm going to explain you the concept of motion. So let's begin. And before going deep into these concepts, let us first understand what is meant by motion. So the definition of motion is any object changing its location with respect to time is called motion of that object. What is relative? Okay, now observe the situation. So, as shown in the figure, two persons say A and B are moving opposite to each other on the road. Now, if we ask a question to the person A that on which side of the road the house is, then the person A answers that the house is on the right side of the road. And now, if we ask the same question to the person B, then the person B answers that it is on the left side of the road. So here, there are two answers for one situation. Thus, the position of the house is relative to the observer. Is day or night just now? The answer depends on where the question is being asked. When it is daytime in Hyderabad, it is night in New York. So here day and night are relative. So here when we are answering, we should keep a frame of reference of the place. And now observe the another situation. For the person standing at A on the globe, his position appears up and the orientation of person standing at B appears down. But for the person standing at B, the situation is exactly opposite. That is, for the person standing at B on the globe, his position appears up and the orientation of the person standing at A appears down. This situation also varies for person C and D. So from those situations, we understood that frame of reference is must and very important. Motion is relative. Observe the situation and the conversation between Srinu and Somesh. Srinu asks what is the state of motion of the tree. Somesh answers that it is at rest. Srinu asks what is the state of motion of the car. Somesh answers that it is moving due east. Srinu asks that what is the state of motion of the driver and the passenger in the car. Somesh answers that they are also moving like a car. Srinu asks how do you decide that the car, the passenger and the driver are moving. Somesh answers that with respect to us, the position of the car, the passenger and the driver are changing with time, so they are in motion. Now, observe the situation and the conversation between driver and the passenger. Driver asks what is the state of motion of the tree. Passenger answers that it is moving due west. Driver asks what is the state of motions of both the person beside the road. Then passenger answers that they are also moving due west. Driver asks that what is my state of motion. Passenger answer that you are at rest. So, from the above discussion, it is clear that the tree is at rest with respect to Somesh and it is moving due west with respect to passenger. The motion or rest of an object depends on the observer. So, motion is a combined property of the observer and the body which is being observed. Distance and displacement. So, suppose this is your house and that's your friend's house and the path of distance is given here. It is about 3 km and the other path is also given here. It is about 5 km. There are many paths to reach your friend's house and the word distance is the length between any two points in a given direction. And the path drawn here is called displacement. It's about 1 km. Displacement is the shortest distance covered by the object in a specified direction. And displacement doesn't have any curves like the distance, it is in a straight path. Now name the displacement, say AB. So if you start from A, then A is called as initial position and B is called as final position. Now I am introducing two new words to you, scalar and vector. A physical quantity which has only magnitude is called scalar. A physical quantity which has magnitude and as well as direction is called vector. As distance has only magnitude but not a direction, so distance is a scalar quantity. And here for displacement, direction is to be mentioned. So its magnitude is 1 km and due northeast direction, so displacement is a vector quantity. A vector can be represented as a directed line segment. Its length indicates magnitude and arrow indicates its direction. Point A is called tail and point B is called head. Okay, let us draw displacement vectors. First one, it's like this and this is the shortest distance, that is displacement of these 2 points. Now, second one, it's like this. Generally, the distance covered and the displacement are time dependent quantities. average speed and average velocity. Okay, let's draw displacement vectors once again. First, Sirpur Khagas Nagar to Khazipet. Second, Khazipet to Hyderabad. Third, Sirpur Khagas Nagar to Hyderabad. Okay, let us do some examples based on numericals. Let the distance of the entire trip from Sirpur Khagas Nagar to Hyderabad be 720 km. The journey time is 12 hours. What is the distance covered by the train in each hour? So as we know, speed is equal to distance by time is equal to 720 by 12 is equal to 60 km per hour. Can you say that the train has covered exactly 60 km in each hour? Obviously, the answer is no, because there may be some variation in distance covered by the train in each hour. So, we take the average of distances covered by the train for each hour to decide its average speed. The distance covered by an object in unit time is called average speed. So, the formula for average speed is equal to total distance by time taken. Now let's do second example. Let the displacement of the trip in the above example be 360 km due southwest direction. What is the displacement in each hour? So the displacement per hour is equal to 360 km by 12 hour is equal to 30 km per hour. And don't forget to write the direction because displacement is a vector quantity. The displacement of an object per unit time is called average velocity. Average velocity is a vector and is along the direction of displacement. So the formula for average velocity is equal to displacement by time taken. The quantities average speed and the average velocity explain the motion of body in a given time interval. They do not give any information about the motion of a body at a particular instant of time, measuring the average speed and the average velocity. Okay, this is the path of the journey and this is the point A, B, C, D and E. The distance travelled from A to B is 6 km, B to C 3 km, C to D 4 km and D to E 1 km. If the time taken to complete the journey is 2 hours, then what is its average speed and the average velocity? So, as we know, average speed is equal to total distance by time taken is equal to AB plus BC plus CD plus DE by 2 is equal to 6 plus 3 plus 4 plus 1 by 2 is equal to 14 by 2 is equal to 7 km per hour. And now, let's find average velocity. If the displacement is 6 km, okay, as we know, average velocity is equal to displacement by time taken is equal to 6 by 2 is equal to 3 km per hour. Okay, now observe the situation. You have started your journey from A and goes to B. And without stopping, you came back again to A. If A to B is 6 km and B to A is 6 km and the time taken is 3 hours, then find its average speed and the average velocity. So average speed is equal to total distance by time taken is equal to 6 plus 6 by 3 is equal to 12 by 3 is equal to 4 km per hour. Now the average velocity is equal to displacement by time taken. So here what do you say about the displacement? So here the displacement is 0 because I have said you earlier that displacement is the shortest distance between the 2 points. But here the same point is the initial position and the final position. So the displacement is 0. So average velocity will become 0 because average velocity is equal to displacement by time taken is equal to 0 by 3 is equal to 0.